Good morning, everyone. Okay, well, what we're going to be doing this morning or this afternoon, depending on when you happen to be watching this, is going through this instruction on plate boundaries for plate tectonics. All right, so please follow along with me. You can have your digital notebook open while you're working on this at the same time. So that might be a good idea. Have this on half the screen and have your digital notebook kind of behind it because I'm going to explain what's going on here. All right. So as we begin, there's three essential questions on plate boundaries. What is plate tectonics? What are the three types of plate boundaries? And what crustal features are formed at plate boundaries? So which one of these do you know? Which one do you not know? Mark those now by, as usual, dragging these to where they need to go. And then check back at the end so that you know whether you've answered them and whether you've gathered all the proper information. All right. So here we go. On our first slide here it says plate boundaries. The continents have shifted over time to their current position. Why are the continents of Europe and Asia different than all the others? Looking at this, each color is a different plate. So why are Europe and Asia different from all of the others? And if you don't get it here, you might see it also on another slide. You'll get this information. So sometimes you might find something later and then go back and do it. So type your answer in here and then we'll move on. So this whole thing about plate tectonics came about because of the two different theories. One, continental drift theory from Alfred Wegener. He developed the theory that the continents drift. At the same time, he didn't know how it worked. So it was difficult for science to accept. But later on, through Harry Hess, he discovered seafloor spreading, where the magma and the mantle was rising and causing the seafloor to spread. So they ended up putting these two theories together, and that's what makes this up. So on this slide, you're going to type in what two scientists created these theories. Again, you can flip back to the last slide and see that, but it's the theory of continental drift and seafloor spreading. So get your answer in there. Here it says plate tectonics is the theory that Earth's outer crust, the lithosphere, is divided into several plates that glide over the plastic-like and less rigid asthenosphere, that is the upper mantle. It was developed from two previous theories, continental drift theory and seafloor spreading. Again, you'll need that information later on, so remember where you saw it. Let's keep going. All right, vocabulary, plate boundaries. So one of the things we're looking at here, write the short definition for the terms lithosphere and asthenosphere. Probably going to get some of that information on the previous slide. Remember the lithosphere, that is, whoops, let me see if I can get in a little closer there. Yeah, so the lithosphere is here. That is the crustal area. See the lithosphere here, and the asthenosphere is this part right here, part of ductile mantle. So on that slide previously, you'll probably get the correct information. So go back and fill that one out. Let's move forward. All right, so if we look at this slide, we'll see there are 7 major plates. There's more than 7 plates, but there are 7 major ones, and you'll need to put the names that you see over on the side here, okay? That is pretty self-explanatory. And then on the next slide, there are some smaller plates. And if you look and see where those are, here they are, the Philippine Juan de Fuca plate, Cocos plate, Naka plate, Scotia plate, Caribbean plate, the Arabian plate, and the Indian plate. So you've got the large continental plates, then you've got these smaller ones. So get those answers in there and just be aware that there are major and minor plates. All right, plate boundaries. What is the engine that moves the plates? Convection currents, it transfers energy in the mantle, causes the hotter magma down here in the mantle to rise, causes the cooler mantle to sink. And this convection current is what causes, see, we have slab pull. This stuff moving to the side is pushing that over in that direction. So type your answer here. Where might you have heard convection before? And for several of you, that answer will be different. Some of you may not have heard it before. Some of you may have. Anyway, put your answer there. All right, plate boundaries. So the first one we're going to look at, continental crust. Continental crust. Layer of rock which forms the continents, also forms the shallow seabeds. Those are the that are close to the continent. That's the continental shelf. It floats on the top part of the mantle. It floats on the asthenosphere. Continental crust is older than oceanic crust. Why is that? Because the oceanic crust, remember, as it comes up in the mid-Atlantic ridge, it travels out to the edges, it subducts underneath the continental crust and ends destroyed. And it's this constant creation and destruction, creation and destruction. The plates have been pretty much floating on top for a long time. So they're very, very old. So again, continental crust is older than oceanic crust, and it's mostly made of granite rock. It's thicker and less dense, which is why it typically floats and oceanic crust goes underneath. We'll continue on. Plate boundaries, oceanic crust, a thin layer of crust that underlies the ocean basins. That lines the large areas of ocean way out here and underneath here. That's all oceanic crust. Younger than continental crust, and it's more dense. All right. Now here is a compare and contrast, oceanic versus continental crust. So what you're going to do is you're going to take these 1, 2, 3, 4, 5, 6, 7, 8 bits of text, and you're going to put them in the correct spots where they go. So there's some things that are specific to oceanic, specific to continental, and then something that is kind of common between them. So you're going to move those into the correct places there. All right, plate boundaries. You've got 3 types. Okay, so look at the diagram to the left. In your own words, describe what you think is happening to the crustal plates in each. Do not look at the next slide. This is where you try and explain things. You're looking at it visually, put it into words. Don't go to the next slide because then your brain stops working. You've got the answers. All right, now we're going to go to the next slide. All right, plates do one of 3 things when they meet. All right, don't peek. Slide this over when you have answered on the previous slide. All right, so what you're going to do is take this and move it out of the way, and it's going to have the answers, okay? So don't look at it yet. This is divergent, this is convergent, this is transform. But what do those things actually mean? All right, next slide. Divergent boundaries. Two oceanic crusts diverge and create a mid-ocean ridge. Diverge means they are pulling apart. They are going away from each other. And creates a mid-ocean ridge, mountains under the ocean. This process is called seafloor spreading. New crust is created, and these are areas where there are ocean ridges, where seafloor is spreading and creating new crust. You got it happening over here also. All right, there you go. All right. Robert Frost wrote a poem in which two roads diverged in a yellow wood. What does diverge most likely mean here? So if two roads diverged, what does that mean? Put that here. All right. More about plate boundaries, divergent boundaries, dividing or moving apart. Two continental crusts diverge and create a rift valley. So this happens under the ocean and on land. So new crust is created. Example is the Great Rift Valley in Africa. Over millions of years, water will eventually fill that valley. So there's potentially a new ocean going to form in that Rift Valley in Africa. All right. Okay, so right here, divergent plate boundary. You're going to take this, one of these, and put the correct symbol over here for what it means to diverge. And then type here, you're going to type in the direction of movement of the plates and description. You're going to give some kind of description of the features, what kind of landforms or features are created there. And then try and give two examples. On the previous slides, it's given you examples of specific areas on Earth where those things occur. Okay, let's keep going. Transform boundaries. These are ones we're more familiar with. This is where two plates slip past each other, creating earthquakes. Crust is neither created nor destroyed at these. Many of these boundaries are found on the seafloor. The most famous transform boundary is the San Andreas Fault right here in California. And you can actually see this fault on land. These are two separate pieces of crust that are sliding past one another. And you can see the boundary between them on land. It's very clear. All right. So on this one, you're going to do the same as you did on the previous slide. For a transform plate, which one of these shows the direction of plates transform? What's the direction of movement? What type of features, land features or landforms are there? And give two examples. We'll continue. All right, convergent plate boundaries, boundaries that are coming together. You have continental oceanic, oceanic, and sometimes continental. We'll get to those. Okay, continental oceanic. This is a subduction zone. These were both subduction zones, oceanic to oceanic. So landform, the Cascade Mountains in Oregon and Washington are an example of this. An oceanic volcanic arc of islands formed. The Aleutian Islands in Alaska. You have Alaska way up north, and then you have that long arc of islands. Those are created by the subduction of one oceanic plate under another. Let's keep going. All right, think about the different types of plate boundaries. How could you prove that those motions were actually happening? For each type of boundary, convergent, divergent, and transform, describe a measurement you could take over several years that would be evidence of that boundary type occurring. How could you prove? Think about it. What scientific equipment or what could you design How could you prove that that was happening there? This is where you got to use a bit of your imagination. All right. Plate boundaries, converging boundary, continental to continental. This is one of the most famous instances that we've talked about here. This is where the Indian plate has run into the Eurasian plate. And since they are both continental crust, one's not more dense than the other, they kind of keep crashing and then they go up. And what we have here are the Himalayan mountains, the tallest mountain range on Earth, at least on land. Okay, two continental crusts collide and push against each other. This pressure causes both plates to rise, creating folded mountains. There's no subduction zone here. All right. Converging boundary, continental and oceanic boundary. All right. The ocean crust goes below the continental crust because it's more dense. Volcanoes form on the continent because as the oceanic crust goes underneath into the mantle, coupled with the water it carries with it, and then the heat, that magma rises back through the continental crust, creating a volcano. And we can see here, this also begins to buckle a little bit and it causes it to rise. And then as this goes into the asthenosphere, it melts and that hot magma rises through the rock to create volcanoes. All right, let's keep moving forward. So volcanoes form on the continent. A trench forms at the place when the plates collide, and this is a subduction zone. All right. Now here's oceanic to oceanic. Like here's one plate here, and then I'm going to show you there's another plate right here moving this way. And this is the space between two oceanic plates colliding. And it's, if you look down here, it's creating this arc of islands. That's the Aleutian Islands of Alaska. That's where two oceanic plates are coming together. They collide and push against one another. The older crust goes below the other one and creates a volcanic arc of islands. This is a subduction zone. One subducts, goes beneath another. All right, we're going to continue on. So here you're going to do the same as you did on those other slides, but for the last three: convergent plate boundary and convergent plate boundary. Ocean to ocean, ocean to continent. So here we've got a couple different things. Put your examples there. Move these plate directions in and move on. All right. So here are a couple of things. You're going to move these three in each. Locations where you see examples, you'll move these to specific locations. And then what causes it will go into these positions. Those will be the plate boundaries and examples. All right. All right, so the Ring of Fire, here we go. The Ring of Fire is this area on the map where volcanoes and earthquakes happen all around this area. So it's a long chain of volcanoes that surround the Pacific Ocean, one of the most geologically active areas on Earth, site of frequent earthquakes and volcanic eruptions caused by the plate boundaries converging, diverging, and transforming. And here we can see a cross section of everything that's happening here. Here's an island arc from two oceanic plates. Here's a hotspot volcano like the Hawaiian Islands. This would be the Aleutian Islands of Alaska. This is like a mid-Atlantic ridge here. And this is an oceanic to continental subduction zone, like off the west coast of North America. And here you have a rift valley like in Ethiopia and Africa happening where new crust is being formed. All right, we'll continue. So, in what ways might the ring of fire have changed in shape and size throughout time? So, imagine if this is seafloor spreading happening and all these things are moving, how might this have been different? And how could a model like a map help us tell if we are correct? Here's where you have to use your imagination and think what's going on? How could that map have helped? What might it have looked like? What might it have looked like? Imagination. All right. We're almost getting to the end here. You're going to move these guys where they need to go. So you'll move this one where it's supposed to go, and you'll take these and put them where they are supposed to go. All right. Oops, where did I go? I went too far. Hang on. Where did I go? I almost went back to the top. All right. So here we go. So you'll move those where they're supposed to go. All right. And on this one, this is where you figure out, have I learned most of this? This is where we're looking for understanding. So this is really important that you answer these questions. So this may take you 2 days to get through this slideshow, but the last few questions on these pages, make sure you can answer them, because that's how you're going to show me that you've understood the material that we've gone through. So give your best answer. Explain plate tectonics. Don't look it up on Google. Do your best to put it in your own words. All right, name 3 types of plate boundaries and describe their movement. You've done that on the slideshow before. Give your best answer. Relate plate boundaries to the formation of crustal features, such as mountains, trenches, volcanoes, and ridges. So what type of boundary is it? And what kind of features are at those boundaries? The next one, which essential question do you still need help to understand? So go back to the top here to these essential questions. Which one don't you know? Which one do you still need help with? Write that question here, because I'm going to look at this and see who needs what. That's going to be our next step. What do we still need to work on? Okay. I hope you found this helpful. I hope you figured out most of the information here. We're going to go over the next day or two on this, and we have a quiz on Wednesday on plate tectonics. So if you do this, you should do well. I will say good luck. And if you have any questions, please don't hesitate to ask.